Okay, welcome back to part 2 of our chapter 1 discussion. We just finished talking about physical changes and we gave some examples. I think I want to move on to chemical properties, and then we'll talk about chemical changes and give some examples. I'm going to try to keep these videos to about 15 minutes a piece. Don't want to make them too long. You usually have to watch 1, maybe 2 of these a night. Just to keep up with our notes. And of course, reviewing these videos are a great way to prepare yourself for an exam, and of course to help you on your homework. Alright, let's jump right into it. Again, let's talk about chemical properties right now. Remember, we just talked about physical properties not too long ago, and we said those are properties that do depend upon the amount of matter that's present. A chemical property is a bit different. A chemical property is a substance's ability to undergo changes hopefully all of this is on the camera for us, to undergo changes that transform it so a substance's ability to undergo changes that transform it into different substances. Now that sounds a little bit confusing, doesn't it? Let me just give you a couple of examples and you'll say, okay, that makes sense. A chemical property of iron. Let's see. We have a substance, iron. What does iron have the ability to do that can actually transform it into something that's different chemically? Well, I claim that iron can rust. Don't you guys agree? If I take a piece of iron and throw it outside in my backyard and let it sit out there for a little while, I'll come back in a few days or a few weeks and there'll be some rust that's on it. See, it's no longer the same stuff. It's no longer pure iron. It now has a compound that's formed on it, iron oxide or rust. Let me give you another example. How about silver? Do you guys have any real silverware in your home? What does silver do? What ability does it have to undergo a change that can transform it into something new? I claim that silver can tarnish. Right, it gets that black coating on top of it. So that black coating is no longer silver. We've transformed it into something new. And how about one more just for fun? How about gasoline? What can gasoline do really, really well? I think gasoline can burn really, really well. After we have burned gasoline, do we still have gasoline? Of course, we don't have gasoline any longer. We have carbon dioxide and water vapor, don't we? We've transformed it into a different substance or substances. Okay? All right, let's talk about a chemical change now. A chemical change is a change in which one or more substances a change in which one or more substances are converted into different substances. So it's a change in which one or more substances are converted into different substances. Let me give you a pretty simple example. Let's say I take hydrogen gas. That little G in parentheses means that we have the gaseous form of hydrogen. And I chemically react it with oxygen gas. Now, if I were to mix these two together, I would have hydrogen and oxygen gas mixed together. It would be a nice homogeneous mixture. However, if I react them together, I can actually change their properties from the properties of hydrogen and oxygen gas, and I can make water vapor. Now I've changed them into a different substance. Water has completely different properties than hydrogen and oxygen. So I've changed them into something new, and that's called a chemical change. Now when I write this type of chemical reaction out, these things I begin with are called reactants. So the reactants in this chemical change are hydrogen and oxygen gas, and the things I end up with are called products. And in this case, I have one product, and that's water gas. Now something with a G after it we sometimes call vapor. So sometimes we'll call this water vapor instead of water gas or gaseous water, just for your information. Now this is your first example of a chemical reaction. It's not balanced. We're not going to worry about that right now. I'm just showing you what a chemical reaction is. The things you begin with are the reactants. The things you end up with are your products. All right, let's talk specifically about a few elements. There's a list at the beginning of your manual of about 50 elements. I have their properly spelled name and their symbol. And you're going to have to learn those properly spelled names and symbols over the next couple of weeks. We use them quite a bit throughout the entire year. Now, the ancient chemists were called alchemists. Merlin the magician was an alchemist. They discovered several elements and other materials that they thought were elements. As more elements were discovered, a new system of symbols was developed by the Swedish chemist Berzelius. Many of these symbols will need to be memorized. Make sure you learn not only the symbol, but also the properly spelled name of the element. That should be name of the element. Sorry, there was a typo in your notes. Now it turns out that 11 of these elements have symbols that are derived from a name for the element other than the English name. Now these are common, and their symbols have to be learned. The elements and their other names are given here. So for the most part, the symbols for an element make sense. For instance, if I have the element hydrogen, its symbol would be H. If I have the element oxygen, it's O. The element nitrogen is N. And the element lithium, that's 2 letters in that element symbol, and that's Li. However, there are some elements, it turns out that there are 11, whose element name, whose element symbol comes from a name other than an English name. For instance, the element iron, the symbol is not IR. The other name for iron is a Latin name, and that's called ferrum, and that's where the symbol is derived from. So the symbol for iron is Fe. Now notice how I write that symbol. There are 2 letters in the symbol for iron. The first letter is always uppercase, and the second letter, if there is a second letter in the symbol, is always lowercase. We do not write this for the symbol of iron, nor do we write this for the symbol of iron. Those would be incorrect. If there are 2 letters in the symbol, the first letter, remember, is the uppercase or capital version of the letter, and the second letter is always the lowercase version. Copper comes from the Latin name cuprum. The symbol for copper is Cu. Lead comes from the Latin name plumbum. The symbol for lead is Pb. Once again, notice the second letter and the symbol is the lowercase b. Now you'll notice that I like to write in uppercase letters. However, whenever I write the symbol for an element, and if there are 2 letters in that symbol, the second letter is always lowercase. Tin. This is one that students often miss. They want to write Ti for the symbol of tin. That is wrong. Ti is the symbol for titanium. Tin comes from the Latin name or its symbol comes from the Latin name stannum. It is S-N. Let's do a few more here. Gold comes from the Latin name aurum. It is A-U. Silver, argentum, that is A-G. Now sometimes students will get these two mixed up because they would love the symbol of gold to be AG because there's a G in it. It is not. Silver is argent, comes from the Latin term argentum, and it is AG. Gold comes from the Latin name aurum, and it is AU. Mercury comes from the Latin name hydra argentum. Now think about this. Argentum is silver. What do you think of when you think of hydra? Do you think of something like water? Maybe a watery silver? It turns out that mercury is one of just a couple of elements that are liquids at room temperature. The symbol for mercury is Hg. Sodium comes from the Latin name natrium. It is Na. Potassium, the Latin name is kalium. It is a K. So if there's only one letter in this symbol, it's always the uppercase version of that element, or of that letter. Antimony, another one that's often missed, comes from the Latin term stibium. The symbol for antimony is Sb. And the last of the, we'll say, strange element symbols is tungsten. Tungsten comes, its symbol comes from the German name, which is wolfram. So that is just an uppercase W. Like I said earlier, at the beginning of your notes, there are several elements whose spelling and symbol you must know. Most are obvious. So for instance, if I had you write the symbol for carbon, I hope you guys would write C, an uppercase C. What do you think the symbol for helium is? It is He. Notice the second letter is lowercase. Hydrogen is the uppercase H. You should also be able to go backwards. If I gave you the symbol F, you should know what element that is. That is the element fluorine. Now fluorine is spelled F-L-U-O-R-I-N-E, not O-U. We don't call it flourine. It's fluorine. What if I gave you the symbol Cl? What do you think that is? Cl is the element symbol for chlorine. And if I gave you the element symbol I, the capital letter I, that is iodine. And like I said, there's quite an extensive list, and we'll have some quizzes to help encourage you to learn the properly spelled name of the element and its proper symbol. Okay, that's it for today. We'll keep it short. We're going to talk a little bit about the periodic table in our next discussion. I hope you've enjoyed your time today. Thanks. Bye-bye.